All right, so this question here says solve by factoring, check your solutions. And so what we want to do is we want to take a look at this quadratic, and you want to break it into the two binomials, right? So it's a trinomial, so we're going to try and break this up into two binomials like this. And the nice part about this is that this a value is just a 1, so that's going to make this easy. What we do is we just focus on, we're going to put the x here and x here, because those multiply to x squared. That's the easy part. And then you want to focus on the numbers that multiply to 21 and add up to 10. Okay? So this one is multiply here, and this one is add. And what two numbers multiply to 21 and add up to 10? Well, 1 and 21 they multiply to 21, but they don't add to 10, right? What's another combination of factors? 3 and 7. Okay, that multiplies to 21. Does that add to 10? Sure does. So we go plus 3 and plus 7. Now, these are the factors right here. See, x plus 3 is a factor, and x plus 7 is a factor. So in order to solve by factoring, we're going to use the zero product principle. Remember that? Product principle. And so that means in order for this side to equal 0, then one or both of these have to equal 0. So if I let this one equals 0 and solve for my x, it's going to be x equals negative 3 is going to be one solution. That's what's going to make this factor 0. And then over here, x plus 7 equals 0, or x equals negative 7. That's my other solution. So to check, now we think that that's what we have, but to check, let's put each of these values separately into the original equation to see if the left side is going to equal the right side. So 0 equals, this is 9 minus 30 plus 21. Well, 9 minus 30 is negative 21 plus 21. That equals 0, so that checks out. And the other one, negative 7. So we have negative 7 squared plus 10 times negative 7 plus 21. So this is 49 minus 70 plus 21. 49 minus 70 is negative 21 plus 21, so that equals 0, so that's good too. So here's our check, and these are our solutions right here. We'll just finish that off. X equals negative 3, x equals negative 7. Does that make sense? All right. Okay, so here's another example where we have an a value that's negative and it's not 1, right? So this one might be a little trickier. It is an equation, so remember you can add things to both sides. You can multiply or divide both sides by the same thing. So if you don't like the negative here, guess what? You can just multiply or divide, whatever. You can divide both sides by negative 1. And then you can actually get rid of that negative on the first term. And then this sign changes here. And that sign changes there. So you can get rid of that negative right away if you want. No problem. You can also divide out from both sides a common factor if you want. So look at, I'm going to divide out 3. So 6z squared divided by 3 is only 2z squared. 21 divided by 3 is 7z. And 9 divided by 3 is 3. And then 0 divided by 3 is always, it's still 0. It doesn't matter what you divide 0 by, it's always going to stay 0. So you see how I just took some common factors out of those? And that might make it a little bit easier for you to factor now. You can factor by sight, by intuition. You could also factor by using the decomposition method. All right. So I'm going to show you how I would factor this by sight. Because 2 and 3 here are both prime, it's going to be pretty easy. So one of these is going to be 2z and one's going to be 1z. So that's where I would kind of put that at the beginning. Okay, 2z and z. Now you want to put the combinations of. Sorry? Well, because remember, the first two terms here have to multiply to this term. So it's going to be 2z times 1z, because 2 and 1 are the only factors of 2. So 2z and 1z. Okay? Yeah. First terms have to multiply to this one. Yes. That's how we kind of start factoring by sight. Now the next you go over here, you see, over here both of the last terms, including the sign here, both of those last terms have to multiply to 3. Okay? So the combination is going to be either plus 3 and plus 1, or it's going to be minus 3 and minus 1, because they have to multiply to 3. Now look at this middle term. It's a negative value, so guess what? You're going to want to add together negative values. So I would say,
It does have to equal 7 when it adds up.
yep, it has to equal 7 when it adds up. But not these numbers. Those numbers don't have to equal 7 because you have this in here. You see, that's not a 1. So it's not the same as if A was 1. It's not just those two numbers. So watch. You have to first of all check this. Make sure that your first two multiply to this. Then you have to check this one. The last ones have to multiply this one. Now is where you do your quick check in your head, and you do your FOIL like this. So 2z times z is z, 2z squared. That's great. Now I have what? I have negative 6z. See when I multiply those two? See? Outsides?
Yeah.
Negative 6z.
Last one's add or multiply.
Okay, let me just finish. Negative 6z minus 1z. That's what you focus on to see if you add up to this term in the middle. And of course these do, negative 6 minus 1. And then, so if you were finishing your FOIL method to check, first terms would be 2z squared. And the last terms multiply always plus 3. So did we factor this correctly? Well, when you multiplied them out and did a little check here, this is our little check, we see that we do have, this is the exact same as the original one, you see? It simplifies to the exact same. So we've done this part correctly, this step of, and then of course this is going to be equal to 0. And now we do our zero product principle. What? That was just a check. It's not part of the solution. Remember, we're trying to find the values for z that make this original statement true. So what values of z go here and here to make this side all equal 0? How we do that is we solve by factoring. And we factored now into two factors. This whole thing right here, instead of plus and minus different terms, it's now just multiplied by two things. So if this equals 0, if that equals 0, and if this one equals 0, then that's where the solutions for z will be. Okay? So 2z minus 1 equals 0, 2z equals 1. Divide both sides by 2, you get z equals 1/2. That seems to be one solution there. As well, if z minus 3 were to equal 0, then z would be equal to positive 3.
So they add to the last one with the sign on
The add.
9 minus 1 and minus. Oh, wait, no, it's
No,
not.
no, it has to be multiplied. Yeah, it has to be multiplied. Yeah. The only ones that add to, like when you think of this middle term, it's this multiplication, the outside terms, added to this one. So multiply, add to this multiply. They're always multiplying. You're multiplying. You multiply, 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 and multiply, and then you add up all the terms.
Yeah. So to check for the.
So to check, yeah, to check, you would put each of these in separately into the original equation to see if it works. Yeah.
And then because it foils to add up to the 7.
Well, yeah, this foils out to come up with this one. The solutions are what we get out of these binomial factors. The solutions are what we get. Now when you plug the solutions into the original one that you were given, here's the original question right here, then the left side should equal the right side. And those should be the same. Okay, so what we'll do is we'll check this on the graphing calculator, and then we'll take care of kind of 4.12 where we have to solve by graphing. So I'm going to turn this on, clear this, go to y equals, clear all that. So again, on, y equals, clear everything up. Let's put this original equation in. Remember, we're going to treat this as a function and find the x-intercept values. So I'm going to do negative, here's the negative button down here, negative 6 x squared. The plus down here, 21. This is the x button, of course. minus button is on the side, minus 9. So remember, if it's a negative at the front, it's this negative button on your calculator. If it's a minus here, it's a minus on the side, okay? All right, so let's graph this now. Oh, looks like my graph from a previous one is a little out of whack. Well, that's okay. We can kind of see these are the two solutions. If you want to get your screen back to a normal screen, just hit zoom 6. That kind of gets to 10 every way. Okay, so here we can see our intercepts are going to be our solutions. The x values, the intercepts are going to be the solutions. So let's see what we have. Second function trace is the calculate menu. So second function trace. And then we're going to go to 0. So we want to find out what the zeros are. So we have to put the cursor somewhere to the left of the first 0. I see it's blinking there just to the left and down. That's great. So I'm going to hit enter for the left boundary. Then I'm going to either move my cursor. You can move your cursor to the right so it pops up above there. Then put that as your right boundary, and you'll see the two little markers on the screen. And then you just hit enter one more time to get the calculator to guess. Look at that, 0.5. So that would be one of your solutions. If we look back down here, 0.5 certainly is one of our solutions. So that one is correct. The other one would be over here, and it sure looks like we've got 1, 2, 3. It looks like it's a 3. Let's just double check that. So second function trace. Let's do select number 2 for 0 again. So I'm going to put my cursor somewhere over here. Okay, I can do it anywhere here now, to the left of this, to the left side, right? Hit enter. Now I'm going to move my cursor over, or I can just type in a number like this looks like 5 over here. So let's just type in 5 for the right boundary. See how it automatically just goes to 5 and puts a little thing there? So now I can hit enter, and the calculator will guess this intercept, and of course it's 3, 0, so x equals 3, or z, or my variable equals 3. This one is checked out as well. Okay, so you can always check with your graphing calculator, and that's how you'd find your intercepts too. That would be in 4.1 there with the graphing calc, right? Okay. Okay, so let's do. There's only 2 kinds left, which is completing the square, and then quadratic formula. So let's do one of each here. So I'm going to grab a question that looks like this. Complete the square to determine the roots. Whoops. Okay. Whoops. So complete the square to determine the roots of each quadratic equation. Complete the square. So what you have to do with completing the square is you focus on the x squared term and the x term, or the variable squared and the variable, whatever. If it's not x, it doesn't have to be x, it can be whatever. But you want to focus on this first. Leave all this to the side for now. So what we do is we factor a -2 out, because that's the number that's in front of the x squared. You don't want to have any number in front of the x squared here inside the brackets. So I do have to take a -2 out of 16x as well, which gives us a minus 8x. Okay, you see that? So this right here, I've kind of broken this up into this so far. Now I know that I have to complete the square, so I'm going to add a space here, because I'm going to have to make a trinomial that would be a perfect square trinomial here. Now I said I was going to leave this -3 out here for a little while, and of course when I add something or whatever, I'm going to subtract something as well from the same side. So let's find out what number would go in there. Half of 8 is 4, squared is 16. You see that? Half of 8 divided by 2, that equals -4, squared is 16. So by putting a 16 there, I've actually added -2 times 16. See that? So I've actually added -32. Okay, so then I need to subtract a -32 as well. And if you don't like it that way, then I would suggest, doing this. This is a -32, so just add 32 to the same side. Then that'll be fine. Of course, these numbers over here can be combined, and you can put them over to the other side. So I'm going to rewrite this. I'm just going to rewrite this for now. We'll come back to this. So -3 plus 32 is going to be what? 29? Okay, just one step at a time. But the other thing we want to do, though, is we want to get complete the square to determine the root. So I do need to solve for x. So let's do a little bit of, let's do this. What's that?
At the perfect square trinomial.
Yeah, it's a perfect square trinomial, so I can now write this
Then
as x minus 4 all squared. You see that? This,
perfect square trinomial just means you can write it as one binomial.
yeah, it means you can, well, a perfect square trinomial means you can write this as a binomial all squared. Yeah, it's there's two identical factors for this.
We're factoring, making the perfect square.
Yep, that's the whole, completing the square, that's the whole point. Completing the square is putting a number here in order to make this a square, a perfect square. So you're completing an incomplete, so up to this point it's incomplete. You're completing the perfect square. Because you want to write like this because you want x in only one spot. You don't want x in two different terms like we have here. This is no good. You can't isolate for x here, but here now you can. So I'm going to put this.
Making it so you can just then convert it into standard.
Yeah, well, we don't want to convert it to standard form because it's in standard form up here. We're trying to isolate for x. We're trying to get x by itself.
But
Yeah.
it's like, so a perfect square then goes into one binomial
Yep.
square.
Yeah, you write like this. You bet. So I took the 29 to the other side. I'm dividing now by -2, both sides. So I want to get rid of this here. Express your answers as exact values. So I'm going to leave this as a fraction. Okay, so it's going to be 29 over 2. Make sure I've done that right. 32 plus 32. And I'm going to take the square root of both sides now.
Wait, why are you dividing it over two?
Well, I just want to get rid of this 2 here so I can just have my perfect square alone.
So, oh yeah, right, you're isolating for x.
Yeah, I need to isolate for x. So this square root and this square are going to basically cancel each other out, right?
So you're taking out a.
So I'm almost done here. So x equals now plus or minus root 29 over 2 plus 4. I got to get this minus 4 to the other side, becomes a plus 4 over there.
Wait, but how did it go from -29?
Okay, so I'm just going to put this on the, oh, what happened here? I'm going to put this on the graphing calculator. Minus. Put this on the graphing calculator. That's my original equation, -2x squared plus 16x minus 3, okay, as a graph. I've changed the window settings a little bit so we can see the intercepts really well here. So I'm going to check my answers here because I haven't double checked my algebra. I'm going to check it on the graphing calculator. So let's see. Well, first of all, let's see what this decimal is. What's 29? What's the square root of 29 over 2? Let's see. The square root of 29 divided by 2 equals 3.8. Okay, so this is going to be 3.807 plus 4 and negative 3.807 plus 4. So this is going to be, what's that, 7.807, 807 or 808, 808 I guess. Let's round it properly. And then this is going to be like, what, like positive like 0.119 or something? 0.19 or so.
Wait, they're both?
Yeah, they're both positive. Okay, so let's just double check now on our calculator to see if those look like the proper intercepts. So I'm going to do 0. I'm going to do this a little bit quicker. Left bound, I'm going to plug that to be -1. I'm going to put my left boundary over there. And I'm going to go 1. I could go 2 here. And then 2 is my right bound. You see how I've just kind of plugged those values in. And then now I'm going to get the calculator to guess what the intercept is between there. So 0.19. Look at that. 0.19. So this is looking pretty good so far. And then we'll do the same thing to the other one. We'll go 0, and I'm going to go something like 5 maybe. Where's 5? For my left bound, right about there. And then I'm going to go, what's this, 6, 7, 8, 9. Let's go 9 for the right boundary. Awesome. And then enter. That should be about 7.808. There we go. So these are the correct solutions for that. And we did that by completing the square, and we checked by finding the roots on our graphing calculator. Okay, you ready for a quadratic equation?
Yeah.
All right, so before we use the quadratic formula here to solve, let's talk about the discriminant. It's b squared minus 4ac, right? Now remember, on the quadratic formula, and I'll write it down here, negative b plus or minus root b squared minus 4ac all over 2a. So b squared minus 4ac, this is the part that's underneath the root sign. So we learned that if the discriminant, that is the value of b squared minus 4ac, if d equals, well, let's make that another color. If d equals a negative value, then there are no solutions. Why? Because we can't take the square root of a negative number, right? So if this comes up negative, we don't go any further, there's no solutions. If d equals 0, then there's one solution. Because the square root of 0 is just 0, so it's like you're doing negative b plus or minus 0. That's just plus 0 is the same as minus 0, so it's just one solution. It's negative b over 2a. And then if the d is positive, anything greater than 0, then we have two solutions. And you'll see in your textbook that these are no real solutions, one real solution, two real solutions, and you'll find out why that is in PreCalculus 30 next semester. So A here for this question is negative 3, B is negative 2, C is 5. You agree with that? So let's find out before we solve what kind of solutions we may have. We may have no solutions. Be nice to know that right away. So let's try that out. So b squared minus 4ac is my discriminant. That's going to be negative 2 squared minus 4 times negative 3 times the c value of 5. That's going to be 4. A negative times a negative is going to be a plus. 12 times 5 is 60. So we've got 64. Awesome. It's positive. And it's actually a perfect square. Ooh. We could actually add to this side if we wanted to. If it's a positive perfect square, and you don't need to write this down, but if it's a positive perfect square, that means we're going to have like integers or fractions. We're not going to have like radicals in our answer. It's going to be like a whole number or an integer or a rational number anyways. Rational, not irrational. Irrational has a root sign in the final answer. That's irrational. Rational. So this is going to be rational for sure. Okay. Why is what? All right, so let's actually do the formula here. So if we have x equals negative b, which is negative 2, plus or minus root b squared minus 4 times a times c all over 2a, this is what we get. Now remember, this is going to give us our 1 or 2 solutions to this right away. We just plug everything in, and it's going to give us our solutions. So it's going to be 2 plus or minus the square root of, we said that was 64 over negative 6. So this is awesome because root 64 is going to turn out to be a whole number. It's going to be just 8, right? So 2 plus or minus 8 all over negative 6. Those are our two solutions. Or x equals 2 plus 8 is 10 over negative 6. And 2 minus 8 is negative 6 over negative 6. So this simplifies to what? Negative 5 over 3 and positive 1. All right, so to check these answers, okay, you could plug them in and check them algebraically to see if the left side equals 0 when you plug each of these, or you can graph them. We're going to graph these here. Oops. So negative 3x squared minus 2x plus 5. I'm going to graph that. So what does that look like? Looks like this. So I'm going to check to see if these intercepts are the same as the numbers that we got here. So second function, trace 2 is 0. Let's do the left boundary first. So I'm going to move my cursor over. There we go. That's to the left. And move it over. There we go. That's to the right. And enter one more time. Negative 1.66. Yeah, that's negative 5 over 3. That's the same. Okay. And then we'll do it again for the other one. 2. Oh, whoops. I didn't mean to do that. That should work, but I don't want it to get confused. So let's go over here a bit more. There we go. Let's make that the left boundary. That the left boundary, right boundary, and then we'll hit enter again to guess, and this one should be 1. There we go. So that's how you find the intercepts on your graphic calculator, and that's how you can check. And so you would highlight those or circle those as your answers. There are your solutions. Okay? I think that gives you a little bit of everything for chapter 4. So 4.1 really is like a graphically. 4.2 is solved by factoring. And then complete the square to solve. That was this question.
And
Quadratic formula.
For 4.2, that meant the